All right, for now, for the fun stuff. Now, I don't know how I'm supposed to say this name. Everybody who says it a little bit differently. I always have said Le Châtelier's principle, but if you look on the internet, I'm sure everybody says it a little bit different. But I'm going to continue saying Le Châtelier's principle, and then we'll go from there. So, the next topic, so we've talked about spontaneity. Well, we've talked about dynamic equilibrium, then we talked about spontaneity, and now we're going to talk about this thing called Le Châtelier's principle. Le Châtelier's principle is if a system is at equilibrium and it is disturbed, we can predict the response of the equilibrium or of the reaction using Le Châtelier's principle, which is when a change is imposed on a closed system at equilibrium, the system will shift to counteract the change, aka don't mess with it, right? It's happy where it is. So if you make a change, it's going to undo the change. And we're going to go through a series of videos talking about the different things that could be changed. This first video is on concentration changes. So it's a pretty simple thing to like conceptually. If you increase the concentration of something at equilibrium, the reaction will shift to decrease. It wants to undo the change. So increase the concentration, the reaction will shift to decrease the concentration of that substance that was added. If you decrease the concentration, now that's a little bit of a weird thing. To decrease the concentration, you'd have to have another reaction come in that would combine with one of your reactants, right? It would take something out of the reaction so that there's less of it there to react. And if you decrease the concentration of a species, the reaction will shift to increase the concentration of that substance. Let's look at an example. So here we've got nitrogen and hydrogen reacting to form NH3. And I'm having a moment where I think it's ammonia, not ammonium. Ammonium is NH4. If you were to add more hydrogen into this closed system, what will happen immediately is that the concentration of hydrogen will increase. If you look at this diagram of concentration over time, everything's at equilibrium, right? So all of these concentrations of hydrogen, ammonia, and nitrogen are all constant. There's changes at the microscopic level, but not at the macroscopic level. If your system had a change imposed upon it, like an addition of hydrogen, the concentration of hydrogen would immediately increase. So what's your reaction going to do? Well, it's going to counteract this change. It's going to shift the equilibrium to use up that excess hydrogen. So since hydrogen is a reactant, I'm going to shift to the right. This shift will use up the extra hydrogen, decreasing the concentration of hydrogen and nitrogen, and producing more ammonia. So if you look at the diagram, right, you had this shift, you had the increase in hydrogen. So now the reaction wants to bring the hydrogen concentration back down. The nitrogen will also be consumed, so the concentration of nitrogen will also decrease, but the concentration of ammonia will increase until equilibrium is reestablished and the concentrations will be constant again. So it's a new concentration after the shift, but it's brought it back closer to where it was before. And there's a numerical calculation for this that we're going to be doing in this unit as well. Let's look at what happens if you were to take away some hydrogen. So let's say we had hydrogen reacting with something else, and we had the hydrogen leave the system. If the hydrogen was taken away, the concentration of hydrogen would immediately decrease. To counteract this change, the equilibrium would shift which way? So if you took away hydrogen, you'd want to make more. So the equilibrium is going to shift left so that you can make more hydrogen. This shift will produce more hydrogen and nitrogen, and decrease the amount of ammonia. If we wanted to look at what this would look like on one of these enthalpy or equilibrium diagrams, right, it would be concentration of each species over time. Again, you'd have all of these three. Now, if you do these diagrams, I'm not expecting perfection. I don't know what the concentration of these are coming in at. Just draw them as constant. So I'm going to do it the same as the one above. So we're going to have a constant hydrogen, a constant ammonia, and a constant nitrogen. And then we're going to look at the change. So if the hydrogen concentration is decreased, you're going to have that sudden drop, right? This is where the hydrogen is removed. Your reaction is going to shift to increase that concentration back up. Now, it won't come back up to its original level, but it'll increase again. As you're increasing the hydrogen concentration, you will also increase the nitrogen concentration, which will decrease the concentration of the ammonia. So then the key thing is you'll get to this point where a new equilibrium is established where the concentrations will be constant. So these diagrams aren't essential for like a test idea, but I found as soon as I put them in, I understood a lot more what was going on. So you might want to be able to recognize which graph goes with which scenario, but I won't necessarily make you redraw these. So just understanding when you're controlling a concentration that you get an immediate increase or an immediate decrease of that one species, and then everything goes to counteract that change. So here is an example, okay? Given this equilibrium equation of PCl5 goes to PCl3 plus Cl2, which way would my equilibrium shift if my concentration of PCl5 is increased? So if I increase the concentration of this PCl5, your reaction will shift to use it up. So it's going to shift to the right. If the PCl5 is decreased, your reaction is going to shift to make more, which is going to make the equilibrium shift to the left. A different way of asking this is, let's talk about PCl3 this time. If the concentration of PCl3 is increased, again, your equilibrium is going to shift to use it up, so I'm going to go left. So then the concentration of PCl5 is going to increase. If the PCl3 concentration was decreased, you're going to shift to make more, which means you're going to shift to the right, which means that the PCl5 concentration will decrease. Awesome. Go and try those questions.